Welcome to the video on solving trig equations. So to solve a trigonometric equation graphically, you'll enter each side of the equation into y1 and y2. Then you'll adjust the x values in the window and hit graph. And just a note is to make sure you're in the correct mode, radians versus degrees, because if you're in the wrong mode, the graph will look completely different. Then you'll find all intersections in the specified interval, so your x values would be your solutions. So here, for example, we have tangent of x equals 2, from 0 is less than or equal to x is less than or equal to 2 pi. So the first thing we would do is enter tangent of x into y1 and 2 into y2. So the one side goes in y1 and the other side goes in y2. Then we'll adjust our window. So here the minimum is 0 because that's what our minimum is for x. And then our maximum is 6.283 because I typed 2 pi and that's what it is as a decimal. Then after hitting graph, I found the first intersection. So our x value there is 1.107. So that's our first answer in the interval. And then our second x value is 4.287, so that's our second answer in the interval. So x equals 1.107 or 4.287. And that's how you'd find your solution graphically. Next, we want to solve analytically, so by hand. So to do that, you'll move everything except for the trig function to one side, and then figure out which values there are where the trig function will equal the other number. So for this example, we have 2 sine of x equals 1 on the interval 0 to pi. So 2 sine x equals 1. We want just our trig function over here, so we'll divide by 2. And that gives us sine of x equals 1/2. So we want to figure out when our sine of x is 1/2, or when x equals our inverse sine of 1/2. So if you have a calculator, you could just go ahead and plug that in. But if you don't, you would want to think, okay, when is sine 1/2? So in our unit circle, sine is our y value. So we want to know when y is 1/2. So there's going to be 2 points on our circle where it equals 1/2. And if they're having you solve it by hand, it's probably going to be one of those angles that you can use your hand trick for. And our sine of x would be 1/2 at this angle 30 degrees, which is also pi over 6. And then at this angle over here, which is pi over 6 or 30 degrees this way, so that's 5 pi over 6. So x would equal pi over 6 or 5 pi over 6. And that's how you solve it by hand. A lot of times when solving analytically, we'll come up with quadratic equations. And to get to that point, it might require using trig identities. So if the equation is a quadratic, you can solve by factoring, completing the square, or the quadratic formula. An important thing to note, however, is that when you factor, complete the square, or use the quadratic formula, instead of solving for x, you're solving for sine or cosine of x. So you'll need to then do your inverse trig function to find your actual x value. So here we have 2 sine of x equals cosine of 2x from negative pi to pi. We have a double angle here, so we're going to replace that with one of our options for cosine of 2x. And what we're going to use is the one that has sine squared of x, because we want it to match our sine of x here. So this would be 1 minus 2 sine squared x. So that's equal to 2 sine of x. We want to set that equal to 0. So we'll subtract 1 and add 2 sine squared of x to each side. So we have 2 sine squared x plus 2 sine of x minus 1 equals 0. So now we have a quadratic because we have our squared and then our regular sign and then our constant. We could try to factor, but this equation isn't going to factor because nothing will multiply to negative 2 and add to 2. So instead, we'll use the quadratic formula. So instead of x equals negative b, it'll be sine of x equals negative b, so negative 2, here's our b value here, our a value, and our c value. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that equals negative 2 plus or minus the square root of 4 plus 8 over 4, which is negative 2 plus or minus the square root of 12 over 4. Our square root of 12 is going to be equal to 2 root 3. So negative 2 plus or minus 2 root 3 over 4. We can divide everything by 2, so that would give us negative 1 plus or minus root 3 over 2. So our sine of x equals negative 1 plus or minus the square root of 3 over 2. So then we need to take the inverse sine to get that x equals the inverse sine of negative 1 plus or minus root 3 over 2. So that's how you would solve for x in this equation. So here we have our first IB practice question where the calculator is allowed. It says solve the following equation by hand, then check your answer with the calculator. So we have 2 sine 2x equals 3 cosine of x. We have a double angle here, so we'll swap that out. So we have 2 times our sine of 2x equals 2 sine of x cosine x. So we have 2 sine x cosine x equals 3 cosine x. We'll move everything over to one side. So we have 4 times sine of x cosine of x minus 3 cosine of x equals 0. We can factor out a cosine of x from this side. So we have cosine of x times 4 sine of x minus 3 equals 0. So now we can set each component separately equal to 0. So our cosine of x can equal 0, or our 4 sine of x minus 3 can equal 0. So x is our inverse cosine of 0. So if we look at our unit circle, our cosine, which is our x value, will equal 0 at pi over 2 and 3 pi over 2. But here we actually want it in degrees. So it'll be 90 degrees or 270 degrees, and both of those are within our interval. So x equals 90 degrees or 270 degrees. Now we'll look at our other portion. We'll add 3 to both sides, so we get 4 sine of x equals 3. So our sine of x equals 3/4. So x equals the inverse sine of 3/4. So sine would equal 3/4 around here. So we'll have 2 different angles, but these aren't ones that we can use the hand trick for. So all we know is that x is going to equal the inverse sine of 3/4, which would be this angle, and then 180 degrees minus that. So we have x equals 90 degrees, 270 degrees, the inverse sine of 3/4, and 180 degrees minus the inverse sine of 3/4. So we can double check this with the calculator by entering this part into y1 and this part into y2 and changing our window to be from 0 degrees to 360 degrees. So you'll also want to make sure that your mode is in degrees now instead of radians. So when you graph it, your first intersection will be where x is approximately 48.6 degrees. Your second one is where x is 90 degrees. Your third one would be where x is 131.4 degrees. And your final one is where x is 270 degrees. And if we did our inverse sine of 3/4, we would find that that's 48.6 degrees. And 180 degrees minus that is our 131.4 degrees. So this would be your answer to this problem. Now we have our second IB practice question, which is no calculator. It says find the solution to the following equation. 2 sine squared x plus 5 cosine of x plus 1 equals 0. and that's going to be from 0 to 4 pi. So here we have two different trig functions, and we want to make it so that it's only one. So our Pythagorean identity is that sine squared of x plus cosine squared x equals 1. So we're going to want to swap this sine squared of x for cosine squared x. So our sine squared x equals 1 minus cosine squared x. So this will become 2 times sine squared x, which is 1 minus cosine squared x, plus 5 cosine of x, plus 1 equals 0. So 2 minus 2 cosine squared x, plus 5 cosine x, plus 1 equals 0. We'll combine our like terms to get negative 2 cosine squared x, plus 5 cosine of x, plus 3 is 0. We'll divide by a negative 1 so that our first term can be positive. So we'll have 2 cosine squared x minus 5 cosine of x minus 3 equals 0, because 0 divided by negative 1 is still 0. So now we'll see if we can factor this. So we would have 2 cosine squared x in the top corner, and in the bottom right corner we'd have negative 3. So we need something that multiplies to 2 times negative 3, so to negative 6, and adds to negative 5, which is our b value. So this would be a negative 6 and a positive 1, because negative 6 times 1 is negative 6, and negative 6 plus 1 is negative 5. So we have negative 6 cosine of x and 1 cosine of x. So then we can factor out 2 cosine of x from here, plus 1 from here, a cosine of x from here, and a negative 3 from here. So this becomes 2 cosine of x plus 1 times cosine of x minus 3 equals 0. So now we can separately set each component to 0. So we have 2 cosine of x plus 1 equals 0, and cosine of x minus 3 equals 0. So we'd subtract 1 from this one, so 2 cosine of x equals negative 1, and then we divide by 2 to get cosine of x equals negative 1/2. In our unit circle, our cosine is negative where x is negative, so it would be negative 1/2 at these angles here. So our reference angle would be pi over 3. So this angle here would be 2 pi over 3. And then this angle here would be pi plus pi over 3, so this would be 4 pi over 3. So we have 2 pi over 3 and 4 pi over 3. For this other one, our cosine of x needs to equal 3, which cannot happen, so there's no solutions from this side. So now we need to look back at our interval. So our interval is from 0 to 4 pi. This would be your solutions from 0 to 2 pi. So now you need to add 2 pi to each of these to get your other solutions for the second time you go around the unit circle. So x could equal 2 pi over 3, 4 pi over 3, and then 2 pi over 3 plus 2 pi, which would be 8 pi over 3, and then 4 pi over 3 plus 2 pi, which would be 10 pi over 3. So these are your solutions to that problem. In summary, when we're solving graphically, we enter each side of the equation into y1 and y2. We adjust our x values in the window and hit graph. We find all intersections in the specified interval, and then the x values are the solutions. For solving analytically, we move everything except the trig function to one side, and we figure out the values where the trig function will equal the other number. If we're solving analytically and have a quadratic equation, it might require using a trig identity, and then if the equation is quadratic, we'll solve by factoring, completing the square, or using the quadratic formula. That's all for this video. Thank you for watching.